Hello, this is the first episode of Machine Learning with Python. In this series, I will teach you how to build your own machine learning algorithm from scratch by Python. You can do many things with Python to design algorithm for your job, for your business, and even create a new algorithm. And you can learn how to do this from scratch with Python in this course. Let's start with lists in Python. But before I start with lists, I want to start with types and explain how to extract the types of the variables and data in Python. Every data in Python has types. So to extract type of variable, I write type and put the data inside the parentheses. For example, type 3 returns int. It means type of 3 is integer because 3 is an integer number. But how about type 4.5? 4.5 is a real number, but since real numbers are infinite, but computer only has a limited number of memories, they used floating number representation to hold approximation of real numbers. For example, type of 4.5 is float, but int is a subtype of float. It means somehow int is a subset of float. So if I represent 3 as 3.0, the type of 3 is float. It means if I represent int by 0.0 in the right hand side of that int, I get a float type. We have other types. For example, I can write type of strings, for example, data science, and you can see that Python returns type of data science as is str, which represent strings. We have more complicated types, but these are basic types, and we also have booleans, which is the basic types, but here we need these types in our course. But what is list? List is a collection of data which put in a square bracket in Python and separated by comma. For example, if ls is a list, suppose ls is a list of numbers, for example 6, 7, 3, 2, 5 and 9. Then ls is a list include numbers 6, 7, 3, 2, 5 and 9. But indices in Python started with 0, so the first element is ls of 0. ls of 0 refers to the first element of list ls, and you can see ls of 0 returns 6. Also ls of 1 returns 7, ls of 2 returns 3, ls of 3 returns 2. I can replace 3 with, for example, 8, and ls of 4 is 5, and ls of 5 is 9. But 9 is the final element of the list, so if I put ls of 6, it returns error because 6 is out of range of index in the list of ls. But if I put ls of -1, it actually returns me the last element of the list. And this is because if I see this list as a circle and put 6 in the from left to the right to the left hand side of 9, then the first element within this index 0 is 6, but the previous one, the index of previous one should be -1, but previous one in this circle is 9, which is the last element. The second last element of the list is ls -2, and also we could have ls -3, and with minus indexing we could extract final elements of the list. And this is very important for us, especially when we want to extract final element of the list and we don't know the length of the list. But length of the list extract by this command len of ls, and it represents the number of elements in the list. In this example, we have 6 elements in the list ls. But we could extract elements of the list with some specific index. So slicing of a list refers to a process of extracting element of list from a start index to an end index. For example, in the previous list, I can extract element of list from index 2 to index 5. So as you can see, it returns elements of the list ls with index 2, 3, and 4, but it doesn't include index 5, and this is how slicing works. And also we could add, for example, if I put 6 here, if I put 6 here, it also includes 9. But if I want to skip 2 and 9 and scan the element of list with some step size, for example step size 2, then I can do this by this command ls name of the list, square bracket, first index for a slicing, second index of a slicing, and a step size, for example 2. And you can see it extract the index 2, it ignore index 3, it extract index 4, it ignore index 5, and it doesn't extract index 6 because the final index is not included in the list. Also, we could have reverse indexing. For example, ls from 6 to 2 with a step size -1 means we could start from 6 with moving to the left of the list until index 3 to extract element of the list. And this is especially very good when we want to reverse a list. But before we do reversing a list, let's introduce this notation that start with colon and, for example, index 4. It means returning the element of list from the beginning until index 4, and we know that index 4 is not included in the list. So this command returns index 0, 1, 2, and 3. Also, we have alternative notation for element of list started from a given index. for example, ls of index 4 until the end. When I put nothing here after colon, it means scan all element of the list from index 4 until the last element, and you can see that it returns 5 and 9. But what's happened if I put nothing before colon and after colon? It means a scan element of the list from beginning to the end, and you can see that it scan all element of the list. But if I put step size here, ls from beginning to end with a step size -1, it actually reverses the list from 9, 5, 2, 8, 7, and 6. And this is very good when we wanted to reverse element of a list. But let's introduce append and pop in Python. Append actually add elements to a list, and at each step with recalling append, we add one element at time at any time to list. For example, ls, we put name of the list dot append keyword, and for example, I want to append number 10 to the list, and you can see that for example, if I print ls, you can see that 10 is added to this list. And note that append works only for a single element. So for example, if I write ls dot append 11 and 12, you can see that it produces error because it says append takes exactly one argument, but two argument here we put two arguments here. But if I put an extra parenthesis here, it sees tuple 11 and 12 as a single element and append this single element to the list. So for example, if I print ls, you can see that this element as a tuple added to the list, and you can see our list 1, 2, 3, 4, 5, 6, 7, 8. It has 8 elements, but if you include also 11 and 12, you can see maybe that it has 9 elements. But if I return I write len of ls, which means length of the list, it returns 8, and you can see it sees this element as the single element of the list. Also, another way to see this is that if I extract the last element of the list, and we have seen that the last element of the list is by -1 indexing, ls -1 returns tuple 11 and 12, and you can see that this is the last element of the list. But what's happened if I want to delete some elements of a list? And this is very simple. Just write the name of the list, put a dot, and write pop parentheses and the index that you wanted to delete from the list. For example, if I put 2, it means remove index 2, which is 8 in this example, from the list. And you can see that it pops 8 from the list, and if I get an update from the list ls, you can see 8 has been removed from the list and we have a list with one less element. But if I don't put any index in the pop, it returns the last element of the list, and the last element of the list was tuple 11 and 12, and you can see that this list, from this list we have removed the last element, which was 11 and 12. We could also do sorting on the list. By sorting, we means put element of the list from the lowest value to the highest value, or reverse, from the highest value to the lowest value. For example, if I want to sort a list ls, you can see the list ls is not sorted because the first element is less than the second element, but the second element is greater than the third element. A sorted list is a list that the first element in this list should be less than the second element should be less than the third element, and so on. So if I want to sort the list ls, I put the name of the list, a dot, and a sort command with parentheses. Nothing's happened so far because ls.sort just update a list ls by sorting it. But if I print list ls, you can see that we have a sorted list which the first element is less than the second element is less than third one and is less than fourth one, and so on. And you can see this happened in this list. But if I need to sort a list by reverse order, I put the same command, but inside the parentheses I say reverse equal true, and it sort the list with reverse order. And you can see this sorted list, which the first element is greater than the second element, and so on. This was the end of episode 1 of machine learning with Python.